Hello. Right, this one's on vectors. Now there are three types of vector problems that we can do, and the first one we are going to do is finding our way around a triangle. Now, what is a vector? And I'll put little arrows. Now, a vector is a line that tells you the direction you're going and how far you're going. So here's a line from A to B, and we put an arrow on there to show that we're going that way. So no matter where you are, if you start from A and go along this vector, you will always end up at B. Now we call this little vector A. So if I have another vector down here and I call that one A, it's exactly the same as this one. It's the same direction and it's the same length. It doesn't matter where you start from, you will do the same thing. Now if we have another vector starting at A, but this time it's only half as long, then it will be half the vector A. And if we have a vector that is twice as long as the original A and we go that direction, then that will be 2A. So all the vectors go in the same direction, they're going the same way, and they're different lengths. So you can go up the vector, but you can also go back down the vector. So if we go to our original vector there, A to B, and we call that A, if we travel that side, that direction, we can say the vector from A to B, see the arrow is the direction we're traveling to, equals the little a. So to get from A to B in this direction, we need to travel along using this vector A. Now if we're going to go the other way against the arrow, then it would be the vector of B to A, and because we're going the wrong way against the arrow, it would be minus A. So go with the arrow, it's plus, go against the arrow, it's minus. So let's look at some problems about how we use these vectors in exam style questions. So we'll have A, B and C. So we'll call that one vector A and that one vector B. Now, so we've got in this triangle, we've got vector AB is equal to A, vector BC, that direction, is equal to the little b. Now you get the question where you have express vector AC going from A to C in terms of A and B. Now the mistake that a lot of people fall into is they will just go put an arrow on AC and call and do this. Well, AC is vector C, but this is wrong. We can't use the letter C, we've got to use the letters A and B. So let's wipe that out because it's wrong and replace it with what we know. So to get from A to C, we're going to explain or express what this vector is, the direction and the length, but we can't go directly from A to C yet. So to find out what the vector of A to C is, we're going to go all the way around with what we know. So the vector of A to C is, first of all, we've got to go up here from A to B, so that will be a little a, and then we're going to go down the other side from B to C, and that will be the b. So if we go up to the top and back down to C, we've gone a vector A plus B. So that in effect is A plus B. So the vector to get from A to C, if we go in a direct route, is going to be A plus B. So let's do the other way around. So we'll go from C to A. Now, if we, with the knowledge that we've got here, all we're doing is going backwards along that one, or we can go up there and round the top. So if we go up there and round the top, we'll say we're going to, first of all, we're going to go backwards against the arrow for the B, so that will be minus B. And then we're going to go against the arrow for the A, so that will be minus A. So it's minus B minus A. And if you look at this one here, from A to C is A plus B. So from C to A, we're going the wrong way, so we just change the signs, minus A minus B. The letters are the wrong way around, but it makes no difference. Minus A minus B is the same as minus B minus A. So that's how we get from one to the other. So let's do a four-sided shape. Yeah? And we've got A, B, C, and D. So this is vector A. I'm going to make that a bit longer. D over there. And we're going to make that vector B, and we're going to make that vector C. Now this is a trapezium. So the properties of a trapezium is the top and bottom are parallel. Okay, and we're given some information that AD is double BC. So the line at the bottom is twice as long as the line at the top. Now they're going in the same direction because they're parallel. So, so this is a B, but it's twice as long, so it becomes 2B. So that might be the first task, is to label up AD. Now, if we're going to go from A to D, so the vector A to D going in that direction, so we go up the A, along the B, and along the C. Yeah, adding. But we've just thought that AB was 2B. Yeah, so AD is also 2B. So 2B means that the A and the C must be equivalent to a B, but added together. Yeah, because if we look at this, we've got the A is that way and the C is that way. Yeah, so there's the A, there's the C. So if we did that, yeah, if we move that line C back to there, it would be exactly the same as B. So A plus C is equal to the vector B, because this line is twice as long, and we move the diagonal back, and then we've split the AD line in half. So that's why you get two answers. You think, how can that be? All you need to do is just move the line along, and you see that A plus B plus C is in fact the same as 2B. There's another one. So we call A, B, C, D. Let's call that A and call that B. And we're in a more complicated. We want to find the vector A to, oh, want to find the vector D to C. Now the problem we have here is there's nothing going on. There's nothing going on here. Nothing going. So normally we go up that one, across the top, and down the other side. But we don't have a down the other side. So how do we do this? Well, know that this is a rectangle. Yeah? And with a rectangle, from parallel, same length, so this is also B. This is also B. Yeah? So from D to C, it's just simply B. Now, we could go another way. Let's go a completely different way to get from D to C. First of all, we'll find the vector DB, which is this diagonal line. Yeah. So that vector is, to get from D to B, we're going to go up the A, across the top, and the B. So that is A plus B. So we could then go up the A, along the B, down the A plus B, and then along the B at the bottom. So we could zigzag all the way through. So if we're going to go, let's go this route. We're going to go up there, across there, down there, and then along there. Long way round, but that's it. So to get from D to C, we're going to go up there, the A, and then we're going to go along the top, the B, and then we're going to come back down here. Back down here. So we're going against the arrow, so this is minus A minus B, and then we go along the bottom plus B. That can't be the same as this way, can it? Let's look. We've got an A minus an A that cancels it out. We've got a B minus a B that cancels out. Now all we're left with is B. Exactly the same. Yep. So it doesn't matter which way round you go, how you find your route. If you're slow and steady, you're always going to get the same thing. Now we could have gone another way around. We could go this way, and this way. And the only problem we had earlier on with that one was that we didn't know what BC was. But hey, it's a rectangle, so it's going to be exactly the same as that. So to go that green way, we would go from D to C, and that would be up the A, along the B, and back down this way, which is against the arrow, so it will be minus A. And we've got A minus A, which leaves us with a B. So no matter which way round, we're always left with that. Right, the other way is column vectors. Column vectors. I think I'm going to go onto a bit of graph paper to explain this. So column vectors are written something like 4 and 2. Something like this. Two numbers on top of each other in a big bracket. Now, the top number is the X, and the bottom number is the Y. And depending on whether or not these are positive or negative tells us the direction we're going to go. So if this is a positive, we go right. If this is a negative, we go left. And the y, if it's a positive, we go up, and if it's a negative, we go down. So you've got 4 choices, yeah? The combination of these. So we can say, let's start a coordinate of 2, 2. So there's our 2, 2, is where we're going to start. And we're going to follow the vector 4, 2. So 4 is the x, and it's a positive, so we go right 4 places. And the y is 2, which is positive, so we go up. And that's where we end up. Yeah, and that would be our vector. And you wouldn't have to label this up A's and B's and things because we don't know. But we'd use the horizontal and the vertical lines as our working out, and we'd use the vector, the diagonal line is the actual vector that we would draw. And so by starting at 2, 2, following the vector 4, 2, we start there, we end up here, and we end at this coordinate 6, 4. Let's just do another one of these. So we're going to start at -4, -2. We're going to follow the vector 8, -8. And where do we end up is the question. Where do we end? So start at -4, -2. -4, -2 is there. Follow the vector 8, -8. So the first one is the x, that's a positive number. So we go 8 to the right. 2, 4, 6, 8. And the next one is the y, is -8. So we go 8 down. So we go 2, 4, 6, 8. So that's where we end up. And I'll just draw. There's our vector. And I'll put an arrow on that because that's the way we're going from the start down to the bottom. And we end up at 4, -10. Good. So we can be asked to do that. Now, the final part of this is where we have to add and subtract column vectors. So we have a column vector of 3, 4, and we call that vector A. And then we're going to add vector B. Whoa, it's getting big. Vector B. 6, 8. Yeah. So add those two together. What we do with these, we just add the x's together because vector A says we've moved along 3 to the right. Vector B says we moved along 6 to the right. So we just simply add the two numbers at the top to give us 9. Add the two numbers at the bottom, the y's, that will give us 12. So that's 9, 12. Now, how about the same things? What is 2a plus b? So we know what a is, we know what b is. So if we want to find out what 2a is, we just multiply these numbers by 2. So we've got 6 and 8. So that's 2a. And this one is 6 and 8. So we simply add them together to give us 12 and 16. And that is 2a plus b. So what is 3a minus 2b? Right, so 3a is going to be this. So we need to triple this original number. So that's going to be 9 and 3 fours are 12. So that's 3a minus and 2b. So we need to double this original one. So that's going to be 12 and 16. So 3a minus 2b will be 9 minus 12 is minus 3. 12 minus 16 is minus 4. And that is just about everything to do with vectors. Apart from, we'll just do one of these triangle ones and we'll just make the vectors just a little bit more complicated. So we've got a triangle here, what we're doing, and this is 2i plus 2j. That's the vector going in the uphill, and we're going to have a, b, c. And this one goes to the left, and it's minus 3i plus j plus j. So what do we need to find? Find the vector BC. Right, BC. So we're going to go there and there. Now, so the going from B to A, so we're going to go all the way around that way, yeah? So we're going to, first of all, the vector BC is going to be minus 3i plus j. Then this is a plus 2i, we're going with the arrow, plus 2i plus 2j. So we've got minus 3i and plus 2i, so that will be minus I, plus j plus 2j is plus 3, collecting like terms, isn't it? Yeah? No. And then we have an extra little bit that is a bit complicated. So let's do this. So you add a new line. And what is this new line? B to D is going to be the new line. And it's twice the length of BC. So here is BC, and yeah, D. So we need to find the vector B to D. Now, we've already found what B and C is this. So this is the vector, the minus I plus 3j. So BD is twice as long, so twice as long, but it's in the same direction. So it's exactly the same as this, but twice as big. So it will be minus 2i plus 6j. So that's vectors. Okay,